Hello and welcome to this video on numerical methods. So this is the second solution video on numerical differentiation involving finite difference using the forward difference method. Now let's consider this question. It says, in an engineering workshop session, students were taught practical and demonstration of a slider crank mechanism in linear motion along a fixed rod. If its distance x meters along the rod calculated every second from start up to 5 seconds, that is t equals 0, 1, 2, 3, 4, 5, is given by x equals exponential t minus exponential minus t. Find the velocity of the slider crank and its acceleration at t equals 0 seconds in 2 decimal places using an appropriate difference equation method to numerical differentiation. Okay. Now, our key equation S was given. S is equal to exponential t minus exponential to the power of negative t. So we simply call this our function f of x equals exponential t minus exponential negative t. That's our function. Now, we are asked to find the velocity and acceleration when t is equal to 0. So when t equals 0, we have to find velocity and acceleration unknown. We have to find the velocity and we have to find the acceleration values. Now, we are given the range of time. So the time given to us is from 0, 1, 2, 3, 4, and 5. These are the appropriate times given to us. Now, we are being told to find the value of the velocity and acceleration when t is equal to 0. So you see that this time can be broken into 6 different places, which is 1, 2, 3, 4, 5, 6. And the middle of this time is between 2 and 3. So from what we've done so far in numerical differentiation, you observe that from 0 to the middle of 2 to 3 is called the forward table. From the middle of 2 to 3 down to 5 is called the backward table. So if the value we are to solve or the point of interest lies at the forward of the table, we will simply employ the forward difference method to solving this problem. Okay, now you observe that we have to find velocity and acceleration when t is equal to 0 and t is very beginning of the table. So which means t lies at the forward of the table, which means we are going to be employing the forward difference method to solving this problem. Now, if we know this to be the function itself to be our distance, then velocity can be obtained by differentiating the function with respect to time. So velocity is equal to differentiating f of x with respect to what? Time. This gives us our velocity. So this simply means find the first approximate value of the derivative using the forward difference method. And using the forward difference method, we know that our first derivative, dy all over the x, is given simply as f of x plus h minus f of x all over h, where h is called the interval. And what is interval? Interval simply means difference between successive values, in this case successive values of the time t. So our interval h is equal to, it can be 1 minus 0, it can be 2 minus 1, any one you choose, but the interval still remains 1. So 1 minus 0 is still going to be what? 1. So this is our interval. Now, having found the interval, okay, having found the interval, let's now find f of x plus h from the formula. So we need to find f of x plus h, but x itself is the time or the point of interest to which we are to carry out this differentiation. So what is the time? When t is equal to 0. So it means x is equal to what? 0. So f of x plus h simply means f of x is 0 plus h is 1, which is equal to what? F of 1. So which means find the value of the function when the time is equal to 1. Keeping this aside, then we find from the formula f of x. F of x simply means, remember x is 0, the time to which we are to find this velocity. So it becomes f of 0. Okay. Now from the given function, f of x itself is simply exponential t minus exponential minus t. So now we find f of 0 simply means plugging the value of x to be 0 or the value of t to be 0. So in this case, please, this can be f of t instead of f of x, guys, because this is exponential t. So this can be f of t. But just to explain that f of x simply means the function itself given to us. So in this case, it's f of t. So f of x plus h here can also be written as f of t plus h, right? Since the function itself is a function of time, t. So this can be f of t plus h instead of f of x. So you can simply call this f of t plus h, and this is f of t. Okay, so which means we are going to alter the derivative a little bit. So of course, the derivative will also be f of t plus h minus f of t all over that. All right, so it's basically the same thing, right? So now let's find f of 0 when the time is equal to 0. This becomes exponential 0 minus exponential to the power of negative 0. Now, exponential 0 is 1 minus exponential to the power of negative 0 is also 1. This is going to be equal to 0. So this implies that f of 0 is equal to 0. Now we find f of t plus h simply gives us f of 1. So we find f of 1, which means in place of t, putting the value as 1 second, that becomes exponential 1 minus exponential to the power of negative 1. So let's see the value we are going to obtain. So we punch exponential 1. Exponential 1 simply gives us 2.7183 approximately. So we have 2 points. Okay, let's use 2 decimal place since the question asks us to find this value in 2 decimal place. So we use 2.72 minus, let's find exponential negative 1. Exponential negative 1. This simply gives us 0.97 approximately. So we have 0.97. So this implies f of 1 is going to be equal to. So let's find 2.72 minus 0.97. That gives us 1.75. So f of 1 is simply 1.75. Now let's plug into the derivative equation. So velocity is simply the first derivative, which is the f of t all over the t. So this is going to be equal to, from what we said, f of x plus t, sorry, f of t plus h, okay, f of t plus h minus f of t all over h, where h is the interval, and we obtained the interval earlier as 1. So this is equal to f of t plus h, which is this, gave us 1.75. We have 1.75 minus f of t, which is f of 0, gave us here to be 0. So minus 0 all over h is equal to 1. This is equal to 1.75 divides 1. So this simply implies that the velocity is 1.75 meter per second. So this is the velocity given that function. Now, the next stage, we should find the acceleration also when t is equal to 0. Acceleration simply means the double derivative of the distance, or simply the single derivative of the velocity function. So if we take the second derivative of the displacement or distance, we simply have what? The acceleration, second derivative with respect to time. So which means in order to find the acceleration, we are now going to be employing the second derivative approximation test of the forward difference equation, since we're using forward difference, right? So the second derivative test becomes what? Not forgetting, acceleration is the squared f of t all over the t squared. So we are using the second derivative test now for the acceleration, and that is equal to f of x, or f of t in this case, plus 2h minus 2f of t plus h plus f of t all over h squared. So this is the formula we use for our second derivative approximation. Okay, so let's plug in these values. We know what t is, remember, when t is equal to 0. Not forgetting our interval h is equal to 1. We simply plug in everything into the equation, right? Okay, so let's do it and see. So we have that acceleration is equal to, this becomes f of t is 0 plus 2h. H is equal to 1. So 2 times 1 is 2. Okay, minus 2f of t once more is 0 plus h is 1 minus f of t is 0. So f of 0 all over h squared, and h is 1 all squared. So this is going to be equal to, right, so plus f of 0. So pretty much everything has been solved, right? All over h squared, and of course h is 1, so that's 1 squared. And this is going to be equal to, so over here 0 plus 2 is 2, so you have f of 2 minus 2f of 0 plus 1 is 1, so that gives you 2f of 1 plus f of 0, and you have f of 0 all over 1 squared remains 1. Okay, so up next, you know the function f of t is given as exponential t minus exponential to the power of negative t. So you simply plug in the values in place of 2. So you simply plug in the values to find f of 2, f of 1, and f of 0. So f of 2 simply means, in place of t, putting the value as 2, that's going to be equal to exponential 2 minus exponential to the power of negative 2. And if you do this by punching your calculator, you have the value to be 7.25. Similarly, f of 1 simply means plugging the value of t as 1 in this equation. So f of 1 becomes exponential 1 minus exponential to the power of negative 1. And that simply gives us 1.75, right? Okay, so you find f of 0. Of course, we've gotten this earlier. F of 0 is 0. If you plug in the value of t as 0, exponential 0 is 1 minus exponential to the power of negative 0 is also 1. So you have 1 minus 1, which is 0. So f of 0 is actually 0. So you plug that into this equation for acceleration. Acceleration becomes what? In place of f of 2, we had f of 2 to be 7.25 minus 2f of 1, which is 2 times f of 1 gave us 1.75, plus f of 0, and f of 0 is 0, so plus 0 all over h squared, which is 1 squared, which is 1. Okay, so this gives us 7.25 minus 2 times 1.75 simply gives us 3.5. So 7.25 minus 3.5, that gives acceleration to be 3.75 meter per second squared, and that's the value of the acceleration according to that question. All right, guys, so that's how to employ the forward difference method to solving numerical differentiation problem. In the next video, we are going to be looking at the central difference method. I'm sure you want to be a part of that video, so do well to smash the subscribe button right now and turn on your notification bell so you don't miss out on that video when it drops. I hope to see you in the next video. Thanks.